Good morning class. Today we are going to discuss about the dissociation or ionization of acid and bases. Students, as we have assumed or we have understood the concept of acid and bases, now we are going to see that how the dissociation of acids and bases takes place. Students, talking about some acids like HCl, like HNO3, like H2SO4. So these are basically hydrochloric acid, nitric acid, sulfuric acid. So when they dissolve in water, they dissociates almost completely and thus producing a large number of H plus ions. Hence these acids are called strong acids. Okay, these acids are termed as strong acids. Students, on the other hand, some acids like CH3COH, that is acetic acid, HF, H2CO3, H3PO4, etc. dissociate only to a small extent, okay, in aqueous solution. So they give a small amount of H plus ions and hence are called weak acids, okay. So they are termed as weak acids. Similarly, students, for bases, some bases like NaOH, KOH, etc. dissociate almost completely in aqueous solution, producing a large number of OH minus ions, hence are called strong bases, okay. Whereas there are some bases like NH4OH, CaOH whole twice. They dissociate only to a small extent in aqueous solution and therefore releases lesser amount of OH minus, hence are termed as weak base. Okay. So students, as we have understood the concept of strong acid, strong base, weak acid, weak base. So from now onwards we can understood the concept of dissociation. Okay, so that from where we have to understood or see the equilibrium. So students, as we are talking about the strong acids, so when HCl is dissolved in water, complete dissociation takes place, that is it forms H3O plus ion and Cl minus, better you can say it as H plus ion, okay. Here you can see this is an irreversible reaction, so it cannot be understood via equilibrium, okay. Now here we will see the concept of weak acid or weak base. So students, you can see here acetic acid, that is a weak acid, okay. When its aqueous solution is taken, it dissociates partially into CH3CO minus and H3O plus. Similarly, a weak base, that is ammonia, when dissolved in water, it partially dissociates into NH4 plus and OH minus. So students, here you can see the arrow that is showing equilibrium state, okay. So we can see the dissociation of weak acid or weak bases in water. It can be represented as an equilibrium process, okay. Students, here you have to recall one more thing which we have earlier studied also. So for the general reaction, suppose we are considering a weak acid as HA, okay, and it dissolves in water and it dissociates into A minus plus H3O plus, okay. So for this reaction, okay, applying the law of chemical equilibrium, we can write down the equilibrium constant K is equal to molar concentration of A minus into molar concentration of H3O plus upon molar concentration of HA into molar concentration of H2O. And students, as H2O is solvent, its concentration is large and it remains almost constant, okay. So we can put the value of K into H2O, okay, as Ka, that is the dissociation constant of an acid. So Ka will be equal to molar concentration of A minus into molar concentration of H3O plus upon molar concentration of HA. Or alternatively, we can write down the dissociation constant of acid is equal to molar concentration of H plus into molar concentration of A minus upon molar concentration of HA. Okay, so this equation can be helped in the calculation processes. So for this, and alternatively we can also similarly we can also talk about the weak bases. So for weak bases, the ionization constant, or you can say the dissociation constant of base, will be equal to molar concentration of B plus into molar concentration of OH minus upon molar concentration of BOH, because as we are talking about the bases. So these are the concept of the dissociation or ionization of acids and bases. Thank you, class.